Okay, hello Cloud Gurus, and welcome to the very last lecture in the S3 and IAM section of the course. So congratulations, you've completed your first theoretical and practical section of the course. So we're going to look at everything we learnt in this section. So we learnt that identity access management consists of the following. So it consists of users, groups, roles, and then you apply policies to these three different things. So you apply a policy to your users, groups, and roles. If you apply a policy to your group and you've got users within that group, they're going to inherit that policy automatically. Now I know we didn't really cover off roles much in this section of the course. We are going to look at it in more detail in the next section of the course. We did create a role when we turned on cross-region replication. So if you actually go into IAM and have a look at your roles, you'll see a role there for cross-region replication. We also learnt about JSON. So this is what policies look like. So it's JavaScript Object Notation Language. Now IAM itself does not come up much in the Certified Solutions Architect Associate exam anymore. It's all been moved to the security specialty. That being said, you can't actually use AWS without knowing IAM. So it is really important to understand the core concepts of IAM and what users, groups, roles, and policies are. We also learnt that IAM is universal. It does not apply to regions at this time. The root account is simply the account that's created when you first set up your AWS account, and it has complete administrator access. New users have no permissions when first created, and you'll find this is a theme within Amazon. It's called least privilege. So whenever you create a new user, that user is not going to have any rights or any privileges until you grant them privileges. Likewise, when we look at S3, when we create our bucket, it's locked down, it's not public, and making objects public is not that easy. You have to go through a process to do it. So that's a common theme within Amazon Web Services. New users are assigned an access key ID and secret access key when first created. These are not the same as a password. You cannot use the access key ID and secret access key to log into the console. You use it to access the AWS via the APIs and the command lines, however, and we are going to look at that in the next section of the course. And you only get to view your access key ID and secret access key once. If you lose them, you have to regenerate them, so make sure you save them in a secure location. So moving on, the final bits we learned about IAM is you always set up multi-factor authentication on your root account, and you can also create and customize your own password rotation policies. So moving away from IAM, let's look at S3. So remember that S3 is object-based. It allows you to upload files, and those files can be 0 bytes all the way up to 5 terabytes, and there is unlimited storage, and you store your files in these things called buckets, and it's basically just a folder in the cloud. Now S3 is a universal namespace, so that means that your bucket names must be unique. You can't have test bucket because somebody already owns it. You can't have a Cloud Guru because somebody already owns it, and it's not me, sadly. And this is what the URL looks like when going to S3. So it's always S3, then the region, and then .amazonaws.com, and then / your bucket name. Now remember that S3 is object-based storage, so it's not suitable to install an operating system on or a database or anything like that. And then when you upload objects to S3 or files to S3, your browser is always going to get a HTTP 200 status code that the upload has been successful. Now by default, all newly created buckets are private. You set up access control to your bucket using bucket policies, and bucket policies are bucket wide. And then you can also use access control lists, and these can go down to the individual files or objects in your bucket. And remember that S3 buckets can be configured to create access logs, which logs all requests made to the S3 bucket. And these can be sent to another bucket in the same AWS account, or even another bucket in another AWS account. And we go into that architecture a lot in the security specialty. There's certain ways you can design your AWS infrastructure to be super secure using multiple accounts. Moving on, the key fundamentals of S3. So basically S3, you've got a key, and this is simply the name of the object. You've then got a value, and this is simply the data. It's made up of a sequence of bytes. So sometimes people refer to S3 as a key value pair. We then have the version ID, which we saw when we turned on versioning. We have metadata, so we have data about data that we're storing, and we do that through tags. And then you get some sub-resources such as access control lists and then torrents as well. Now remember the consistency model going into your exam for S3. So it's read after write consistency of puts of new objects, and eventual consistency for overwrite puts and deletes. And this can take some time to propagate. And like I said, what does that mean in everyday language? Well, if you put an object into S3, you're going to be able to read it immediately. If you overwrite an object or delete an object in S3 and you read it instantly after that, you could get the old version or you could get the new version. So sometimes you will get eventually the right version, but sometimes it takes some time to propagate. Then, seriously, this is a big exam topic. It's worth at least 4 or 5 marks. You have to understand the different S3 classes of storage. So we've got S3 standard. That's what most people use. S3 infrequently access. So this is where you want the same sort of durability and availability as standard S3, but you want to pay a lower fee, but you still need instant access to S3 infrequently access. We then have S3 one zone infrequently accessed. This is what's only going to be in one availability zone, so you have to plan for that, but it is a much lower cost. S3 intelligent tiering uses machine learning to move your objects around depending on how often you use them. S3 Glacier is for data archival, and you can configure your retrieval time from minutes to hours. And then we have S3 Glacier Deep Archive, and this is basically Amazon's lowest cost storage class, but you will have a retrieval time of 12 hours. Moving on, let's talk about encryption. So encryption in transit is achieved by using HTTPS and TLS. So every time you go and visit, let's say google.com, if you've got HTTPS in the browser, that means that traffic is going to be encrypted. So if someone is in the middle trying to listen to that, they won't be able to figure out what it is you're viewing on Google. So that's how we do encryption in transit. So in terms of how this relates to S3, whenever you go to aws.amazon.com and you go into the S3 console, so long as you're using HTTPS, all the traffic, all the files that you're uploading are going to be encrypted. So that's encryption in transit. Now, S3 also has encryption at rest, and this is achieved by both the server-side encryption as well as client client-side encryption. On the server side, it's achieved by 3 different ways. So we've got S3 managed keys. This is where S3 just handle all our encryption for us, and we don't have to worry about it. We've got AWS Key Management Service, or KMS. This is where we can start using keys from the KMS service, and we cover this in an awful lot of detail in the Certified Security Specialty. And then we've got server-side encryption with customer-provided keys. So this is where you provide your keys and you manage the encryption and the actual maintenance of those keys. And then we also have client-side encryption. So this is where you encrypt the objects and then you upload them to S3. So that is encryption with S3 on AWS. Moving on to cross-region replication. Basically, you just need to understand what it is. It is definitely worth 1 or 2 marks in the exam. Versioning must be enabled on both the source and destination buckets. Regions must be unique. You can't do cross-region replication to the same region because then it's not cross-region. And then we have files in an existing bucket are not going to be replicated automatically when you turn cross-region replication on. All subsequent updated files will be replicated automatically. Delete markers are not replicated, and deleting individual versions or delete markers will not be replicated. So basically, going into your exam, it's really important to understand what cross-region replication is at a high level, and that's it really. Moving on to lifecycle policies. So what is a lifecycle policy? Well, basically, it automates moving your objects between the different storage tiers. That's all the policies are. And they can be used in conjunction with versioning, and they can be applied to current versions as well as previous versions. Moving on to S3 transfer acceleration. So we have our users, they're all around the world. We have our edge locations. Our users will upload their files to the edge locations first, and then those files will go over the AWS backbone network to S3. And we saw how mostly it can improve speed and performance. So if you do need to increase the performance of your of your users being able to upload files to S3, look at S3 transfer acceleration. Moving on to CloudFront. So we learned what an edge location was. So this is the location where the content is going to be cached, and it's separate to an AWS region or availability zone. We learned what an origin was. This is the origin of all our files that the CDN will distribute, and this can either be an S3 bucket, an EC2 instance, an Elastic Load Balancer, or Route 53. And then we learned what a distribution was, and this is simply the name given to the CDN, which consists of a collection of edge locations. And then we have 2 different types of distributions. We've got our web distributions. This is typically used for websites. And then we've got RTMP. This is used for Adobe Media, and it's used for media streaming. Also with CloudFront, we learnt that edge locations are not read-only. You can write to them as well, i.e. put an object to them. So we looked at that with transfer acceleration. And then objects are cached for the time to live, or TTL, and that value is always in seconds. And then you can clear cached objects by invalidating them, but you will be charged. So do remember that. Snowball, seriously, you just need to understand what Snowball is. So basically, it's a big disk that you can use to move your data in and out of the AWS cloud. And Snowball can be imported into S3, so you can import data into S3. You can also use Snowball to move large amounts of data out of S3. Moving on to Storage Gateway. Now, I did this exam just a couple of days ago, and Storage Gateway wasn't there. That being said, it does come up actually in the Solutions Architect Professional exam. So it's just important to understand Storage Gateway, and it may well still come up in the Associates. It always used to. It did for 3 years, so I don't want to risk not teaching it. So we have the different types of Storage Gateway. We've got File Gateway. This is used for flat files that are stored directly on S3, and that's NFS. We then have Volume Gateway. That's iSCSI, and we have 2 different types of volume gateways. We've got our stored volumes, and this means that your entire data set is stored on site. So it's literally a 100% copy of your data being stored on site, and then it's backed up to S3. Then also have cached volumes, and this is where the entire data set is stored on S3, and only the most frequently accessed data is cached on site. And if you get those 2 confused, just look for the word cache. That's all you need to see, or cache, however you want to pronounce it, whether you're Australian or American. We also then have Gateway Virtual Tape Library, and this is used for backups, and it works with really popular backup applications like NetBackup, Backup Exec, Veeam, etc. And it's a great way of getting rid of your physical tapes. And then finally, I would read the S3 FAQ before going into your exam, because S3 is going to come up an awful lot in the Solutions Architect Associate exam. So that is it for this section of the course, guys. You've done really, really well. We're going to go and look at EC2, which is Amazon's virtual machine service in the next section. We're going to learn an awful lot. We're going to start using the command line. We're going to start provisioning web servers, and it is an awful lot of fun. So if you've got the time, please join me in the next section of the course. Thank you. EC2 summary. So congratulations, you're at the end of another section of the course. Hopefully you've learnt an awful lot. The first thing we learnt about was what EC2 is. It's basically just a resizable compute capacity in the cloud, or it's a way of provisioning virtual machines in the cloud. And it reduces the time required to obtain and boot new servers instances to minutes rather than hours or days or weeks or months, depending on where you work. And it allows you to quickly scale capacity both up and down as your computing requirements change. So we have 4 different pricing models for EC2. We've got on demand, and this is where you pay a fixed rate by the hour or by the second with no long-term commitments. We then have reserved. This is where you have a capacity reservation. Contract terms are 1 year or 3 years. The more you pay up front and the longer the contract term, the more discounts you get. We then have spot. This enables you to bid whatever price you want for instance capacity, and basically moves around like the stock market. And we then have dedicated hosts, and this is physical EC2 servers that are dedicated for you. And this can be useful where you've got existing server-bound software licenses, or perhaps regulations saying that you cannot use multi-tenant virtualization. Do remember going into your exam that if a spot instance is terminated by EC2 because the price has changed, you're not going to be charged for that partial hour of usage. However, if you terminate the instance yourself, you are going to be be charged for any hour in which the instance ran. We then looked at our different EC2 instance types, and we came up with the mnemonic Fight Dr. McPixie AU, so in Austin or in Australia, depending on what you want. So there's Dr. McPixie. She's clearly a pixie because she's got wings. She's clearly Scottish because she's wearing tartan. She wants to fight. You can see there's a stethoscope around her, so Fight Dr. McPixie. And like I said earlier, you don't really need to understand every single EC2 instance type going into this exam. Where it does become more useful is if you go on to do the professional level exams, they will test you as to whether or not it's a valid instance type or not. Moving on to EBS, we learned that EBS is basically a virtual hard disk drive in the cloud. So termination protection for EC2 is turned off by default. You can go ahead and turn it on, and that means someone won't be able to accidentally delete your EC2 instances. On an EBS-backed instance, the default action for the root volume is to be deleted when the instance is terminated. And we saw that every time we terminate an EC2 instance, the volume itself gets deleted, the root device volume, but any additional volumes will persist. So that is something to watch out for if you have an EC2 instance with multiple virtual hard disk drives, so multiple EBS volumes. When you go in and terminate that EC2 instance, the root device volume, the volume that the operating system is installed at, will be deleted automatically, but the other volumes will persist. And then EBS root volumes of your default AMIs cannot be encrypted. You can use a third-party tool such as BitLocker in Windows, for example, to encrypt the root volume, or this can be done when creating AMIs. It says their lab to follow, but we did do the lab, and we will cover off the steps involved to encrypt our root volume in a second. And then also we learned that additional volumes can be encrypted. So when we go in and provision our EC2 instance for the first time, we can't encrypt the root device volume, but what we can do is any additional volumes we can encrypt right from the very start. Moving on to security groups, all inbound traffic is always blocked by default. All outbound traffic is allowed. Changes to security groups take effect immediately. So as soon as you open up port 80, that takes effect immediately. And then you can also have any number of EC2 instances within a security group, and you can have multiple security groups attached to EC2 instances. And we did that when we went into the EFS lab. We attached our default security group as well as our web DMZ security group as well. Moving on to, again, staying on security groups. So security groups are stateful. That means that when you open up a port, so if you open up port 80, it's going to be open for both inbound and outbound traffic. Network ACLs are stateless. When you go and do a network ACL, you're going to have to open up port 80, both inbound and then also outbound. So we're going to cover that off in the VPC section of the course. If you create an inbound rule allowing traffic in, that traffic is automatically allowed back out again, and you cannot block specific IP addresses using security groups. Instead, you're going to be using network access control lists. And again, we will see that in the VPC section of the course. And you can always specify allow rules with security group, but not deny rules. Then we looked at EBS. These are the different EBS types. So we've got general purpose SSD or GP2. We've got provisioned IOPS SSD, which is IO1. So those are our two different flavors of SSD. And essentially, if you want your IOPS to go above 16,000, you want to move from general purpose over to provisioned IOPS. We then have hard disk drives. So we've got three different types. We've got throughput optimized hard disk drives or ST1. We've got cold hard disk drives or SC1. And then we've got EBS magnetic. And this is sometimes referred to just as standard as its API name. And that's typically is previous generation. So you might not see that in the exam. With the throughput optimized and cold hard disk drive, basically if you need to optimize throughput, choose throughput optimized. If you just want the lowest cost storage available, use cold hard disk drive. So staying on EBS, volumes exist on EBS. So just think of EBS as a virtual hard disk drive in the cloud. Snapshots exist on S3, and I want you to think of snapshots as a photograph of the disk. And snapshots are actually point-in-time copies of the volumes, and snapshots are incremental. So this means that only the blocks that have changed since your last snapshot are moved to S3. And if you take a snapshot for the first time, it may take some time to create. That's because it's doing its very first one, but then it will only replicate. If you take a second snapshot, it's only going to replicate the deltas, so it's only going to replicate the changes. To create a snapshot for Amazon's EBS volumes that serve as root device volumes, you should always try and stop the instance before taking the snapshot. That will give you a consistent snapshot, but that is optional. You can take snapshots on running instances as well, and you can create AMIs from both volumes and snapshots, and you can actually change EBS volume sizes on the fly, including changing the size and the storage type, and volumes will always be in the same availability zone as the EC2 instance. You cannot have an EC2 instance in one availability zone and then an EBS volume in another. Bear that in mind as well. In terms of migrating EBS, so to move an EC2 volume from one availability zone to another, you just take a snapshot of it, you then create an AMI from the snapshot, and then you use the AMI to launch that EC2 instance in a new availability zone. And likewise, if you want to move EC2 volumes from one region to another, take a snapshot of it, create an AMI from the snapshot, and then copy the AMI from one region to another, and then you use the copied AMI to launch the new EC2 instance in the new region. Encryption, snapshots of encrypted volumes are encrypted automatically. Volumes restored from encrypted snapshots are encrypted automatically as well. And you can share snapshots, but only if they are unencrypted. And you can share snapshots with other AWS accounts, or you can actually make them public as well. Moving on to unencrypted root device volumes. So root device volumes can now be encrypted when you provision your EC2 instance. You don't need to worry about it. But if you do have an unencrypted root device volume that needs to be encrypted, you need to do the following. So you go ahead and create a snap of the unencrypted root device volume. You then create a copy of the snapshot and then select the encrypt option. And then you create an AMI from the encrypted snapshot, and then you use that AMI to launch the encrypted instances. So just like we did in the lab earlier on. EBS versus instance store. So instance store volumes volumes are sometimes referred to as ephemeral storage. Instant store volumes cannot be stopped. If the underlying host or hypervisor fails, you're going to lose your data. And EBS-backed instances can be stopped, however, and you won't lose the data on this instance if it's stopped, and you can reboot both and not lose your data. And by default, both root volumes will be deleted on termination. However, with EBS volumes, you can actually tell AWS to keep the root device volume from being deleted. So you can basically stop it from automatically being deleted. In terms of encrypting root device volumes, how do we do it? Well, we created a snapshot of the unencrypted root device volume. We then created a copy of the snapshot, and when we did that, we selected the encrypt option. We then created an AMI from the encrypted snapshot, and then we used that AMI to launch the new encrypted instances. So that's how we basically encrypt our root device volumes using the AWS console. Don't forget, you can also do it using just software like BitLocker, etc., etc. Moving on to CloudWatch. Remember that CloudWatch is used for monitoring performance. CloudWatch can monitor most of AWS as well as your applications that run on AWS. CloudWatch with EC2 will monitor events every 5 minutes by default. However, you can have 1-minute intervals by turning on detailed monitoring. And you can create CloudWatch alarms, which then go ahead and trigger notifications. And CloudWatch is all about performance. CloudTrail is all about auditing. We're going to have another slide of that coming up. So what can you do with CloudWatch? Well, you can create dashboards, and this will allow you to see what's happening within your AWS environment all around the world. You can create alarms, and this allows you to set alarms that notify you when a particular threshold is hit, like 80% or 90% CPU utilization. We can monitor events, so CloudWatch events helps us to respond to state changes in our AWS resources, and you can also use logs, CloudWatch logs, to help you aggregate, monitor, and store your logging data. And like I said, CloudTrail versus CloudWatch. CloudWatch monitors performance, so think of someone at the gym. CloudTrail monitors API calls in the AWS platform, so CloudTrail will tell you who provisioned an EC2 instance or who set up an S3 bucket, etc., etc. We then learned about the command line, so you can interact with AWS from anywhere in the world using the CLI. You are going to need to set up access in IAM. This gives you an access key ID and secret access key. The commands themselves are not in the exams, but some basic commands will be useful to know for real life. We then looked at roles, because we looked at on our EC2 instance what happens if somebody goes into our secret directory, our .aws directory, which is in our home directory, and then opens up our configuration details. They'll be able to get our access key ID and secret access key. So roles are a much more secure way than storing your access key ID and secret access key on individual EC2 instances. Roles are much easier to manage, and roles can be assigned to an EC2 instance after it's being created using both the console and the command line, and roles are universal. You can use them in any region in the world. We then went on to bootstrap scripts. Bootstrap scripts run when an EC2 instance first boots and can be a powerful way of automating software installs and updates. So we've used it a little bit in this course so far. We're going to use it a lot, certainly in the next section. We're going to create a bootstrap script that installs WordPress, and I'm going to use that to connect to our RDS instances. So bootstrap scripts are incredibly useful as well. We then learned about instance metadata and user data. So it's used to get information about an instance such as a public IP. And to do it, you just run a curl and then 169.254.169.254/latest/metadata. If you want to get your user data is literally your bootstrap script that is passed to your EC2 instance when it first boots up. And again, you just run a curl 169.254.169.254/latest/ and then user data. Moving on to EFS, that was the very last lab. So we learned that it supports the Network File System version 4 or NFS-v4 protocol. You only pay for the storage that you use. You don't need to pre-provision, so you don't need to go in and spin up an 8 gig instance or something like that. It basically grows as you put more files on it and can scale all the way up to petabytes, and it can support thousands of concurrent NFS connections. And remember, if you need shared storage, you can't share EBS with multiple EC2 instances. It doesn't work like that, but you can create an NFS EFS mount, and then you can store your files in there, and multiple EC2 instances will be able to access it. And with EFS, data is stored across multiple availability zones within a region, and in terms of the consistency model, you get read after write consistency. Moving on to EC2 placement groups. Placement group is simply how you place your EC2 instances. There's 3 different types of placement groups. The first one is a clustered placement group. We then have spread placement groups, followed by partition placement groups. A clustered placement group is where you want low network latency, high network throughput. This will be where all your EC2 instances are in the same availability zone and as close together as possible, so that you don't have any sort of latency. Spread placement group, these are for individual critical EC2 instances, so you want to make sure that they are basically in different availability zones and on different pieces of hardware. So if a rack does fail, it's only going to affect the one EC2 instance. It's not going to take 2 or 3 out at a time. And partitioned placement groups are effectively for multiple EC2 instances. So this will be for things like HDFS, HBase, and Cassandra clusters. And this is where you have multiple EC2 instances into a partition, and each partition is always going to be on separate hardware or separate racks from the other partitions. So those are the 3 different types of placement groups. Just remember, the clustered placement group doesn't span multiple availability zones, whereas a spread placement and partitioned placement group can span availability zones. Remember that the name that you specify for a placement group must be unique within your own AWS account. Only certain types of instances can be launched into placement groups, so these will be things like compute optimized, GPU, memory optimized, storage optimized, etc. And then also remember that AWS recommend homogeneous instances within the clustered placement group. So this is where you have the same instance type. You can't merge placement groups, and you can't move an existing instance into a placement group. What you can do, though, is create an AMI from your existing instance and then launch the new instance from the AMI into a placement group. So that is it. You're at the end of the EC2 section of the course. I hope you had lots of fun. Okay, hello Cluggers, and welcome to this lecture. So congratulations, you're at the end of the databases section of the course. In this lecture, we're just going to summarize everything we've learned about our databases. So we learned about RDS. This is used for online transaction processing. It comes in 6 different flavors. We've got SQL Server, MySQL, PostgreSQL, Oracle, Aurora, and MariaDB. We then have Amazon's DynamoDB service. This is a NoSQL database service available to us. We are going to create our own DynamoDB table in the serverless section of the course. We'll get more hands-on with that. We then learned about Redshift, Amazon's data warehousing solution, and this is used for online analytics processing. We then also learned about Elasticache. This comes in 2 different flavors, Memcached and Redis. Memcached is used if we want something very, very simple, whereas Redis is used for more advanced data types and if we need multiple availability zones or if we need to be able to do backups. In terms of relational databases, just remember the following points. RDS runs on virtual machines and you cannot SSH into these operating systems. You cannot log in, so you can't RDP using Windows and you can't SSH to your Linux operating systems. And that is a really important point to remember for your exams. Patching of the RDS operating system and database itself is always going to be Amazon's responsibility because you do not get operating system level access. Remember that RDS is not serverless. However, there's an exception to the rule. There's Aurora serverless, and that is serverless. So almost everything in RDS is not serverless, with the exception of Aurora serverless. DynamoDB is serverless, however. Remember, there's 2 different types of backups for RDS. We've got automated backups, and then we've got our database snapshots. So moving on to read replicas. Read replicas can be multi-AZ, and they are primarily used to increase performance. And this is a very common exam scenario. Basically, you've got a struggling database. It's got very heavy read traffic. Maybe it's a WordPress blog or something like that. How do you increase the performance on that database? And one of the answers is, of course, to add read replicas and to point your EC2 instances to those read replicas. Just remember to enable read replicas, you must have backups turned on. And read replicas can be in different regions as well as the same regions. You can have read replicas around different regions in the world. And read replicas can be MySQL, PostgreSQL, MariaDB, Oracle, and Aurora. The only database engine or RDS engine that doesn't support read replicas at this time is SQL Server. And remember that read replicas can be promoted to a master, but when you do this, it's going to break the read replica. So it's going to break the replication. Remember that multi-AZ is used for DR only. It is not used for performance, and you can force a failover from one availability zone to another by rebooting the RDS instance. Remember that encryption is supported for MySQL, Oracle, SQL Server, PostgreSQL, MariaDB, and Aurora. Encryption is done using the AWS KMS service or key management service. And once your RDS instance is encrypted, the data stored at rest in the underlying storage is going to be encrypted, as well as when you do automated backups, read replicas, and snapshots, they're also all going to be encrypted as well. DynamoDB, serverless, like I said, it's stored on SSD storage. It's spread across 3 geographically distinct data centers. You have 2 different types of consistency. Remember the 1-second rule. So you've got eventual consistency. So if your application doesn't need to read your updated data within 1 second, then you want eventual consistency, and this is what you get by default. If, however, your application needs that data to be updated, always has to have a perfect copy of the data, and certainly within less than 1 second, then you probably want strongly consistent reads. Moving on to Redshift. Redshift is used for business intelligence. It's only available in 1 availability zone right now. When you're doing backups, Redshift has backups enabled by default with a 1-day retention period. Just like with RDS, you can extend this retention period to 35 days. Redshift will always attempt to maintain at least 3 copies of your data, the original and replica on the compute nodes, as well as a backup in Amazon S3. Remember that Redshift can also asynchronously replicate your snapshots to S3 in another region for disaster recovery. Moving on to Aurora. Aurora is seriously cool. It's always going to have 2 copies of your data contained in each availability zone with a minimum of 3 availability zones. So you're always going to have 6 copies of your data. And you can store, you can actually go ahead and take a snapshot of your Aurora database and you can actually share that with other AWS accounts. Remember that 2 different types of read replicas are available. So you've got Aurora replicas and you've got MySQL replicas. And automated failover is only going to be available with your Aurora replicas. And Aurora has automated backups turned on by default. You can also take snapshots with Aurora and you can share these snapshots with other AWS accounts, which is what I said earlier. Elasticache. So remember that you use Elasticache to increase database and web application performance. It does this by caching. If you need multi-AZ, then you're going to be using Redis. If you need backups, then you're going to be using Redis. So that is it for this section of the course, guys. If you have any questions, please let me know. If not, feel free to move on to the next section. Thank you. Okay, hello Cluggers, and welcome to this lecture. Congratulations, you're at the very end of the DNS section. I know DNS is not the most exciting topic in the world, but you do definitely need to know it to be a solutions architect in real life. So you will definitely get Route 53 questions on your exams. It's probably going to be worth around 4 to 5 marks, so make sure you do understand it inside out going into your exam. So let's cover off what we've learned, my Route 53 exam tips. Now, always remember that elastic load balancers do not have predefined IPv4 addresses. You resolve to them using a DNS name. I appreciate we haven't covered off elastic load balancers much yet in the course. We will get that when we move on to the highly available section of the course, and ELBs, ALBs, whatever it is you want to call them, they are extremely important topic for the Certified Solutions Architect Associate exam. You should definitely understand the difference between an alias record and a CNAME. If you just remember that Yellow Pages picture that we had up, so we had all our A records, which was just people's names and then their telephone numbers, and a CNAME was that Bruce Wayne, or I think it was Batman, and then it said C. Bruce Wayne, so that's exactly how a CNAME works. And then given the choice between an alias record and a CNAME in an exam scenario, I would always choose alias. Most of the time, Amazon are going to be asking things like your naked domain name. You need to map your naked domain name or your Zone Apex record to an S3 bucket. what should you be using, a CNAME or an alias record? Well, you want to be using an alias record. And we're going to see how to do that in the serverless section of the course. So some common DNS types, we've got our start of authority record, our NS records, our A records, our CNAMEs, our MX records, and our PTR records. And the following routing policies are available with Route 53. So we started off with simple routing, we then looked at weighted routing, latency-based routing, failover routing, geolocation routing, geoproximity routing, but we had to do that using the traffic flow, and then multi-value answer routing. We also learned all about health checks, so you can set health checks on individual record sets. If a record set fails, a health check is going to be removed from Route 53 until it passes the health check again, and you can set up SNS notifications to alert you if a health check has failed. So simple routing, if you choose simple routing policy, you can only have one record with multiple IP addresses, and you can't have any health checks. If you specify multiple values in a record set, Route 53 will return the values to the users in a random order. So here's our user, they're typing in a DNS address, Route 53 is giving them the first record, and then it's giving them the second record, but we can't have a health check on that one. Weighted routing policies, we've got our user, they're typing in a DNS address, and we're setting weights, so we're sending 20% of the traffic to US East 1, and 80% of the traffic to US West 1. So that's how weighted routing traffic works. Latency-based routing is based on our user's location and the latency, so our South African user is going to visit our website, it's behind Route 53, and essentially they're going to get 54 milliseconds if they use US West 2, 300 milliseconds if they use AP Southeast 2, so of course Route 53 is going to send them to the fastest fleet of EC2 instances first, which is going to be EU West 2. Failover routing, this is where we start using our health checks. So essentially we've got an active passive environment. Our active environment could be US West 2, and our passive environment could be AP Southeast 2. If for some reason our EC2 instances or a region goes down, it's going to detect this using a health check, and it's going to fail over to our passive environment. Geolocation routing allows our European customers to be sent to our European servers, and it allows our US customers to be sent to our US servers. It doesn't have anything to do about latency. It actually physically knows where our customers are, and then it makes routing decisions based on that we configure. So that's how geolocation routing works. Geoproximity routing, as you saw, we could start going down the rabbit hole. This is an advanced networking specialty topic. It is not something that comes up in the Solutions Architect Associate exam or even in the professional exam, but it allows you to create route traffic to your resources based on the geographical location of your users as well as your resources. And to use geoproximity routing, you must be using Route 53 traffic flow. And then finally, we had our multi-value answer policies. And essentially, this is the same as simple base routing, except you get health checks. And so you can have multiple values within your record sets. So we've got our record set in here, and we've got our first and our second. And if one fails a health check, what's going to happen? Well, it's going to remove that from the record set, or it's going to stop serving that record until it passes the health check. So that is it for this section of the course. You've done very, very well. The next section, we're going to learn all about VPCs, and that is crucial to passing your Certified Solutions Architect Associate exam. And it is actually an awful lot of fun. So if you've got the time, please join me in the next lecture. Thank you. Okay, hello Cloud Gurus, and welcome to this lecture. This is the final lecture in the VPC summary section of the course. Congratulations, you've done really, really well to get this far. Hopefully you have a deep understanding of VPCs now, and I would honestly go back and until you can build a VPC from memory with both public and private subnets, as well as with VPC endpoints and NAT gateways, until you can do it all by memory, I would not go and sit the exam. So long as you can do all this by memory, you will almost certainly pass the AWS Certified Solutions Architect Associate course. And also, if you can build out VPC from memory, you're going to kill any job interview because you know exactly what to do. So let's start with VPC overviews, and remember the following. So we thought of a VPC as a logical data center in AWS, and it consists of internet gateways or virtual private gateways, route tables, network access control lists, subnets, and security groups. Remember that one subnet always equals one availability zone, and remember that security groups are stateful. Network access control lists are stateless. So with our security group, all we need to do is go and open up a port. It might be port 80 or port 22, and we didn't need to worry about our outbound traffic. It was all automatic. With network access control lists, we have to do both inbound and outbound. Also remember that you can't do transitive peering with VPCs. They need to be peered on a one-to-one basis, and you can peer between regions. So we then went on to build out our very first VPC, and when we created our VPC, it created a default route table, it created a default network access control list, and it created a default security group. It won't create any subnets, nor will it create a default internet gateway. And just remember that US East 1A in your AWS account can be a completely different availability zone to US East 1A in another AWS account. So the availability zones are randomized between AWS accounts. Remember that Amazon always reserves 5 IP addresses within your subnets, and remember that you can only have one internet gateway per VPC. You can't just go in and add multiple internet gateways to your VPC. You can only have one. Also remember that security groups cannot span VPCs. We then went on to learn about NAT instances. So when creating a NAT instance, you always disable the source and destination check on the instance. NAT instances must be in a public subnet, and there must be a route out of the private subnet to the NAT instance in order for this to work, and that the amount of traffic that a NAT instance can support depends on the instance size. And if you're bottlenecking, what you need to do is you need to go in and increase the size of the NAT instance. And you can create high availability using auto-scaling groups, multiple subnets in different availability zones, and then a script to automate failover. And NAT instances are always behind a security group. To be honest, you don't really want to use NAT instances in the real world. You pretty much always want to use a NAT gateway. And just remember how a NAT gateway works. Essentially, you've got your instance here. It has a route in its route table to the NAT gateway, and the NAT gateway has a route out to the internet. And so when your instance runs a yum update, it's going to the NAT gateway and then traversing out to the instance. And also note that your NAT gateway is not behind a security group. It exists on its own. In terms of NAT gateway, redundancy is available inside the availability zone. It's preferred by the enterprise. It starts at 5 gigabits per second, scales currently to 45 gigabits per second, probably scale even more in the future. You don't need to worry about patching NAT gateways, and they're not associated with any security groups, and it's automatically assigned a public IP address. And when you add your NAT gateway, just remember to update your route table so it has a route out to an internet, and you don't need to worry about disabling source destination checks on a NAT gateway. Also remember that if you have resources in multiple availability zones and they share the one NAT gateway, in the event that NAT gateway availability zone goes down, resources in the other availability zones are going to lose internet access. So just by having a single NAT gateway, you do not have high availability. To create an availability zone independent architecture, what you have to do is create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone in which they're in. Also remember, moving on to network ACLs, so your VPC automatically comes with a default ACL, and by default it allows all outbound and inbound traffic. You then can create custom network ACLs, and by default when you do this, each custom network ACL denies all inbound and outbound traffic until you go in and add rules. And each subnet in your VPC must be associated with a network ACL. And if you don't explicitly associate a subnet with a network ACL, then the subnet is automatically associated with the default network ACL. And you can block IP addresses on specific ports using network ACLs. You can never do this using security groups. Remember that you can associate a network ACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. And when you associate a network ACL with a subnet, the previous association is removed. And remember that network ACLs contain a numbered list of rules, and these are evaluated in order, starting with the lowest number first. And you remember, if we had an allow and then a deny, the allow is going to trump the deny because it's evaluated first. So you must always, if you're going to deny something, you must put it in front of your allow rule. So network ACLs have separated inbound and outbound rules, and each rule can either allow or deny traffic. You can't do that with security groups. And network ACLs are stateless, so responses to allowed inbound traffic are subject to the rules for outbound traffic and vice versa. Moving on to ELBs and VPCs, just remember that you need a minimum of 2 public subnets to deploy an internet-facing load balancer. VPC flow logs, we learned that you cannot enable VPC flow logs that appeared with your VPC unless the peer VPC is in your account. You cannot tag a flow log, and after you've created a flow log, you cannot change its configuration. For example, you can't associate a different IAM role with the flow log. Remember that not all IP traffic is monitored with flow logs, so traffic generated by instances when they contact the Amazon DNS server is not going to be logged. If you use your own DNS server, however, then all traffic to that DNS server is going to be logged. Traffic generated by a Windows instance for Amazon Windows license activation is not going to be monitored. Traffic to and from 169.254.169.254 for your instance metadata and user data is not going to be monitored, and then DHCP traffic is not going to be monitored as well. And traffic to the reserved IP addresses for the default VPC route will not be monitored as well. Bastions, just remember what a bastion is and how it works. So we've got our instance in a private subnet. If it wants to connect out to the internet, it's going to do that using a NAT instance or NAT gateway. If, however, we want to SSH in or RDP into our instances in our private subnet, we do that via a bastion host, and sometimes these are called jump boxes as well. So just remember that a NAT gateway or NAT instance is used to provide internet traffic to EC2 instances in private subnets. A bastion is used to securely administer EC2 instances using SSH or RDP, and like I said, bastions are called jump boxes in Australia. And you cannot use a NAT gateway as a bastion host. Moving on to Direct Connect, just remember what it is. It directly connects your data center to AWS, and it's useful for high throughput workloads, i.e. lots of network traffic, or where you need a stable and reliable and secure connection. And then finally, we move on to VPC endpoints, and VPC endpoints enable you to privately connect your VPC to supported AWS services and VPC endpoint services powered by Private Link without requiring an internet gateway, NAT device, VPN connection, or AWS Direct Connect connection. And instances in your VPC do not require public IP addresses to communicate with resources in the service. Traffic between your VPC and the other services does not leave the Amazon network. So this is what it looks like. We've got our instance. It then connects to our VPC gateway, which then connects onto our AWS services. So this could be S3 or DynamoDB. And there's 2 types of VPC endpoints. So we've got our interface endpoints, and that has a whole bunch of different services that you can connect into. But then we've got our gateway endpoints, and our gateway endpoints are only support 2 services, S3 and DynamoDB. So that is it for this lecture, guys. You've done so well getting to the end of this section of the course. Hopefully you've had lots of fun. Seriously, before you go and sit your exam, make sure you can build out a VPC from memory. This includes public subnets, private subnets, it includes NAT gateways, as well as using a VPC endpoints as well. If you can do all that from memory, then you are almost certain to pass your exam. So that is it for the end of this section of the course. In the next section of the course, we're going to look at high availability. We're going to look at different architectural styles, and then we're going to move on to application services, and then finally we're going to move on to serverless. So if you've got the time, please join me in the next section. Thank you. Okay, hello Cloud Gurus and welcome to this lecture. So we are going to summarize everything that we've learned in the high availability architecture. You've done really well to get through this section of the course. It is one of the most challenging. The only one that's more challenging is the serverless one, which is coming up. So what did we learn in this section of the course? Well, we learned there's three different types of load balancers. If you remember the cars example, so we have our application load balancers. They're layer 7 aware, and they're pretty much what you typically would want to use in production because they can make intelligent routing decisions. We then have our network load balancers. So just remember the Tesla Roadster. This is where you need extreme performance or perhaps a static IP address. Network load balancers are not application layer 7 aware. They only go up to layer 4. We then have our classic load balancers. These are basically where you want to keep costs under control. You don't need intelligent routing and you just want to keep your costs down. So we have the three different types of load balancers. Remember what they are and their use cases going into the exam. Now in the lab, when we were rebooting our RDS instance, it caused our site to go down and we got a 504 error. And this means that the gateway has timed out. So our whole web application is not working. And it could either be our web servers or our database servers. In our lab, it was our database server that stopped working. So just remember that a 504 error means that the gateway's timed out and you need to figure out what's going on with the application. Is this the web server layer, the application layer if you've got one, or database server layer? Moving on, we learnt about with classic load balancers, if you need the IPv4 of your end users, you need to look for the x-forwarded-for header. We then also learned that instances monitored by elastic load balancers are always reported as either in service or out of service. And you can put health checks which check the instance's health by talking to it. So we did that with the healthy.html file. And then load balancers always have their own DNS names. So you're never given an IP address. And by that, I'm just talking about application load balancers as well as classic load balancers. You can get a static IP address for a network load balancer. I would recommend that you go and read the elastic load balancers FAQ. I say in the slide for classic load balancers, I'd read the FAQ for all load balancers. You're going to get about 10 questions on your exam concerning load balancers. And a lot of them are just going to be scenario-based questions as to which one you should choose. You might get a question about gateway timeouts. So if you've got a 504 error, and you might get some questions on, using a classic load balancer, how you get a public IP address. Do you remember? It's using the x-forwarded-for header. And then if you want a deep dive on application load balancers, I appreciate we just went over it in a very sort of high level. We definitely have a deep dive course on the A Cloud Guru platform showing you how to create super intelligent routing decisions. We then went on to learn about advanced load balancer theory. So we looked at sticky sessions, which enable your users to stick to the same EC2 instance. And this can be really useful if you're storing information locally to that instance. We also looked at an exam scenario where essentially we weren't getting connections to another EC2 instance. And the way to enable that was to disable sticky sessions. So sticky sessions can come up in either sort of scenario. We then looked at cross-zone load balancing. This enables you to load balance your traffic across multiple availability zones. And we looked at a scenario where essentially we're having issues where traffic wasn't being routed to a particular instance in another availability zone, and that was because we didn't enable cross-zone load balancing. And then we looked at path patterns, and this allows you to direct traffic to different EC2 instances based on the URL contained in the request. And we looked at myurl.com was going to our web servers, whereas myurl.com was /images was going to our media-based servers, which were in a separate availability zone. And then we looked at CloudFormation. CloudFormation is a way of completely scripting your cloud environment. And then we also looked at Quick Start, which is a bunch of CloudFormation templates already built by AWS solutions architects, allowing you to create complex environments very quickly. And then finally, we looked at Elastic Beanstalk. With Elastic Beanstalk, you can quickly deploy and manage applications in the AWS cloud without having to worry about the infrastructure that runs those applications. You simply upload your application and Elastic Beanstalk automatically handles the details of capacity provisioning, load balancing, scaling, and application health monitoring. And I used an example. Elastic Beanstalk really is aimed at developers who just want to get their stuff into the AWS cloud quickly. They don't want to have to go and learn something like CloudFormation. CloudFormation is way more powerful than Elastic Beanstalk, but again, it takes an awful lot to learn it. If you do want to learn CloudFormation, of course, we have an advanced CloudFormation course on the A Cloud Guru platform. Okay, hello Cloud Gurus and welcome to this lecture. This is the application summary lecture. So congratulations, you've done really well. You've got just one more section left and then you'll be able to go ahead and book your exams and hopefully pass on the first attempt. The next section of the course is super fun as well because we're going to do a whole bunch of serverless stuff. So let's have a look at what we learned, and we're going to start with SQS. So SQS is the way to decouple your infrastructure. So we use the example of a meme website or a travel website. Basically you store your messages in SQS and your EC2 instances will go get those messages and go ahead and do something. If those EC2 instances for whatever reason stop working or are terminated, the message will then reappear in the queue and another EC2 instance will go in and get it. And then that way, if anything fails, it doesn't break your entire application stack. Remember that SQS is pull-based. It's not push-based. If you want push-based messaging, you're going to use SNS. Messages are 256 kilobytes in size. You can actually have them bigger, but it won't be stored in SQS. It'll be stored in S3. And messages can be kept in the queue from 1 minute to 14 days, and the default retention period is 4 days. And then just remember the two different types of SQS. So we've got standard SQS and we've got FIFO SQS, and you have to understand the different use cases for them. So standard, order is not guaranteed and messages can be delivered more than once. With FIFO, order is strictly maintained and messages are delivered only once. So really remember that going into your exam. Remember the difference between standard and FIFO. Also remember the visibility timeout. This is the amount of time that the messages is invisible in the SQS queue after a reader picks up that message. Provided the job is processed before the visibility timeout expires, the message will then be deleted from the queue. If the job is not processed within that time, the message will become visible again and another reader will process it. This could result in the same message being delivered twice. So if you are getting the same message being delivered twice and this is the root cause, you may want to increase your visibility timeout just to give your your EC2 instances that little bit of extra time to process the message. And just remember that the visibility timeout maximum is 12 hours. Also remember that SQS guarantees your messages will be processed at least once. And then long polling is a way to retrieve messages from your SQS queues. While regular short polling returns immediately, even if the message queue being polled is empty, long polling doesn't return a response until a message arrives in the message queue or the long poll times out. And this is a way of saving money with SQS. Moving on to SWF, I appreciate we just sort of glazed over it a little bit. Really, you just need to understand SWF versus SQS because you're going to get scenario-based questions and you really want to pick the right one. So SQS has a retention period of 14 days. With SWF, Simple Workflow Service, workflow executions can last up to 1 year. And SWF presents a task-orientated API, whereas SQS offers a message-orientated API. So you've got a scenario-based questions talking about a task-based structure, and maybe it's got human workers, for example, then you want Simple Workflow. If you're talking about a message-based system, then you're going to go after SQS. SWF ensures that a task is assigned only once and is never duplicated. With SQS, you need to handle duplicated messages if you're using the standard one, if you're not using FIFO, and you may also need to ensure that a message is processed only once. And then SWF keeps track of all tasks and events in an application. With SQS, you need to implement your own application level tracking, especially if your application has multiple queues. Then we learned a little bit about SWF, so Simple Workflow Services actors. So we had workflow starters. These are applications that initiate or start a workflow. Could be your e-commerce website following the placement of an order, or a mobile app searching for bus times. Then have our deciders. These basically control activity tasks in the workflow execution. And if something is finished or failed in a workflow, a decider then decides what to do next. And then we have our activity workers, and these are basically people or programs or applications that carry out activity tasks. If you see anything about a human working in a warehouse and you need a way of managing it, then think of Simple Workflow Service. As I mentioned, Amazon.com use Simple Workflow to help run their warehouses. Moving on to SNS, just remember what it is and the different benefits that it gives you. So it's instant push-based delivery. So there's no polling like with SQS. If you want pull-based, you're going to go for SQS. If you want push-based, you're going to go for SNS. It gives you simple APIs and easy integration with applications. You get flexible message delivery over multiple transport protocols. It's inexpensive pay-as-you-go model with no upfront costs. It's a web-based AWS management console, offers the simplicity of a point-and-click interface. And then just like I said, remember SNS versus SQS. They're both messaging services in AWS, but SNS is push, SQS is pull or polls. Your EC2 instances poll the SQS queue. Moving on to Elastic Transcoder, it's really simple. Just remember that it's a media transcoder in the cloud. It converts your media files from their original source format into different formats that will play on smartphones, tablets, PCs, etc. Then API Gateway, I appreciate that this was quite high level. We are going to get our hands dirty with API Gateway in the next section of the course. API Gateway is definitely worth 5 or 10 marks. So just remember what it is at a high level. It's basically a gateway into your AWS resources, your AWS infrastructure. It has caching capabilities to increase performance. It's low cost and scales automatically. That being said, you can throttle API Gateway to prevent attacks, and you can log your results to CloudWatch using API Gateway. And then if you're using JavaScript or Ajax that uses multiple domains with API Gateway, you have to ensure that you have enabled CORS on your API Gateway, so cross-origin resource sharing. And remember that CORS is always enforced by the client's browser. Moving on to Kinesis, just remember the difference between Kinesis Streams and Kinesis Firehose. Kinesis Streams has data persistence. It's going to store your data by default for 24 hours, but can go up to a longer period of time. So you get your data persistence, and then you have your EC2 instances going in and getting the data from the streams. Kinesis Firehose is where you need to analyze your data in real time and then find a place to store it because there is no persistence. So you could have Lambda functions running in Firehose that then store that data into S3, or they could put it into Elasticsearch clusters, etc., etc. So if you see anything mentioning about shards or about data persistence, you want streams. If you want real-time analytics and then a place to put it in instantly with no data persistence, then you're going to be using Firehose. And you're going to be given scenario-based questions where you must choose the most relevant service. And then you have Kinesis Analytics, which basically helps you analyze your data in both Firehose as well as Kinesis Streams. And then finally, we looked at Cognito. So Cognito allows us to do web identity federation. Federation essentially allows users to authenticate with web identity providers such as Google, Facebook, and Amazon. And essentially the way it works is the user authenticates first with the web ID provider and receives an authentication token, which is then exchanged for temporary AWS credentials, allowing them to assume an IAM role. And Cognito is an identity broker, which handles the interaction between your applications and the web ID provider. So you don't need to go ahead and write your own code for this. And then the main thing to remember for Cognito is the difference between our user pools. So our user pools are user-based, and they handle things like user registration, authentication, and account recovery, etc., whereas identity pools authorize access to our AWS resources. Okay, hello Cloud Gurus, and welcome to this lecture. Well, congratulations, you are at the second last lecture in the entire course, and you've done really, really well. And you've gone through in this section, you've created your own serverless website using API Gateway and using Lambda, and then we've also gone on and created an Alexa skill. And don't worry if you couldn't get any of those labs to work. You really just need to understand what Lambda is and what API Gateway is at a high level. I definitely go back and watch the API lecture in the application section, just so you get a better grip on it. But in terms of what you need to know for this section of the course and what you need to know for your exam, you need to remember the different types of architectures within the cloud. So I like to call this cloud 1.0. This is the more traditional approach. This is where you've got your Elastic Load Balancer, at the front end. You then got your EC2 instances, so these would be your web servers, and then they're storing data in a traditional database like RDS. So that's a very traditional architecture. It still is highly available if you make it that way, and it can tolerate failure if you architect it correctly, but it is limited in how much it can scale. Yes, you can have auto-scaling groups, but where you're really going to start bottlenecking out is your RDS instances. And again, it really depends. Like if you are using Aurora, it probably won't bottleneck out as much as if you were just using a T2 micro with MySQL, but it is not as scalable as serverless architecture. So serverless architecture typically would consist of API gateway, a Lambda function, and then DynamoDB on the back end. And you are going to be given a whole bunch of scenario quizzes, and then you basically ask what is the best way to architect this from both a high availability point of view as well as a cost-saving point of view. And really, you should be going for the serverless architecture model. So API gateway, Lambda, DynamoDB. So in terms of my exam tips for Lambda, just remember that it scales out, not up automatically. So if you have 5 triggers, let's say 5 people upload 5 different images to an S3 bucket, that's going to trigger 5 separate Lambda functions at any given time. Lambda functions are independent, so one event equals one function. Remember that Lambda is serverless. Know what services are serverless. So RDS is not serverless, with the exception of Aurora serverless. Lambda functions can trigger other Lambda functions, so one event can actually equal 10 functions, or 20 functions, or 50 functions, or even a million different functions if functions are triggering other functions. Also remember that architectures can start getting extremely complicated. AWS X-Ray allows you to debug what is happening inside your serverless application, and that's all you really need to know about X-Ray for the exam. Just know what it is. And then Lambda can do things globally, so you can use it to back up S3 buckets to other S3 buckets. You can configure your functions to run at a particular time of day, at a particular time of week, so sort of like cron. You can do a whole bunch of things with Lambda. So Lambda is a global service. And really go in there knowing your triggers, or even better, know what can't trigger Lambda.